Okay, the next thing here would be solving compound inequalities. And the first question I have here is minus 23 is less than 5x plus 2, which is less than 17. Okay, so what do we do? How do we solve these funky equations? Well, remember, you gotta do the same thing to both sides of what you're looking at here. So you want to isolate your variable, which is x in this case. So you want to subtract 2 from both sides here. So minus 2 here, a minus 2 here, and a minus 2 here. All right, so minus 23 and minus 2 is minus 25, less than 5x, which is less than 17 minus 2 is 15. All right, next we want to solve for x. Well, in order to solve for x here, we have to divide this and this by 5, and this by 5. So divide by 5, divide by 5, divide by 5. All right, minus 25 over 5 is minus 5, less than x, which is less than 15 over 5 is 3. So x is going to be greater than minus 5, but less than 3. So if you want to graph that, a number line. Okay, let's find minus 5. Sorry for the shaky board. Let's say that's 0, and that is 3. So, do we draw a dotted, a circle, an open circle, or a shaded circle here for 5 and 3? Well, there is no equals, so it's going to be an open one for each. And then what's in between here is going to be a solution. So check and see, does this make sense? Well, if x is 0, for example, is 0 less than 3? Yep. Is it greater than minus 5? Yep. So it's a solution. Let's see, I don't know, number minus 4. Minus 4 is less than 3. Minus 4 is greater than minus 5. Take a number over here, say minus 10. Minus 10 is not a solution because minus 10 is smaller than minus 5. Take another number here, say plus 5. Is 5 a solution? Well, 5 is greater than minus 5, but 5 is not greater than 3. 3 is not greater than 5. Therefore, that's not a solution. Therefore, this graph is your solution. Okay. So next, try to get the board not to wobble, is this next equation in which you have an OR. Okay, so you have 2 equations basically to solve for right now. So look at the first one here. Minus 5 minus x is greater than or equal to 7, or x over minus 4 is less than minus 1. Solve the one on the left first. Just preference on my part. So you want to isolate x. So add 5 here, add 5. So plus 5, plus 5. So you have minus x greater than or equal to 7 and 5 is 12. And then we divide by minus 1. Get rid of the minus. So minus 1, x, and this is minus 12. What do we do with the greater than or equal sign? Well, if you divide by a negative number with inequalities, you have to change the direction of the inequality. So instead of being greater than, be less than, equal, minus 12. Okay? And then we go to the right side here and look and see what we have here. X over minus 4 is less than minus 1. Well, what do we want to do here? We want to isolate. Again, okay, we want to multiply both sides by the minus 4. So we go minus 4 here and minus 4 to here. So we have x minus 4 and minus 1 is a 4. Okay, question. Okay, do we change the sign, change direction? Let's say we do. We change the direction. We'll multiply it by a minus number. Okay, so that's your solution. So does this make sense? We plug a number in. Okay, if x is greater than 4, it's a solution. So let's say, I don't know, let's say x is 16. Okay? Okay, the original equation was x over minus 4 is less than minus 1. That's the original equation right here. So, does it make sense to change the direction of the inequality here? Because you're doing multiplication, not division. I believe it does, but let's double check. So, if x is going to be, say, make it 16, just because it's easy. Because 16 is divided by 4, excuse me. So, 16 over 4 is a 4. That's to negative. Is negative 4 less than minus 1? Yes. Therefore, this is a proper solution. If we had it the other way around, that this is x is less than 4, we could choose 0. 0 over 4 is still 0. Is 0 less than minus 1? No. It's not a solution. So this is definitely a solution there. And then right here, we go back to the original equation, which is minus 5. Not minus 5, excuse me. Yeah, it is minus 5. Minus 5 minus x is greater than or equal to 7. Okay, here's your solution. X is less than or equal to minus 12. Well, so let's do minus 100. Minus 100 is definitely less than minus 12. So we go minus 100 in here. Minus 100, minus a minus, that's plus 100, right? So that's 100 minus 5 is 95. Is 95 greater than or equal to 7? Yes. Okay, now if it was the other way around, x is greater than or equal to minus 12, we could choose 100. Instead of minus 100, 100 instead. Well, 100 minus is a minus. You add these together, it would be minus 105. Is minus 105 greater than or equal to 7? No. Therefore, this is correct. Changing the sign is correct also. So you have two solutions. X is less than or equal to minus 12, or x is greater than 4. And that is compound inequalities.